Okay, we're going to learn about solving indicial equations by taking logs of both sides. Bearing in mind that there are other videos I've made about other ways of solving indicial equations, and just remember an indicial equation is an equation where the unknown is in the index. So see the little x there? So the exponent or the index makes the indicial equation, okay? The unknown in the index. So there are other ways, like this is one way. It's a good way, but it's not the only way. You might have seen a video perhaps on using the definition of a log, so converting to log form or using the definition of a logarithm. There's, if you've got a graphics calculator, there's graphical methods. There's methods equating the indices, so equating the little exponents together. Okay, they're all covered in other videos. So this one, we're going to be taking logs of both sides. So here we go. Here's this same question actually appears in one of my other videos, which has got an alternate form. It it uses this method here to converting it to log form. So watch that one if you want to know about that. And likewise with the other methods there. There's videos on all of them. So we have 3 to the 2x minus 5 equals 7, and we have to solve for x. Okay, so using the method of taking logs of both sides, you might know about logs, and logs have a base, and that base can be a whole lot of different things. There's all different bases. So which base is it? Well, it doesn't really matter, but if we're going to use a traditional calculator, okay, now sorry my emulator's not working at the moment, but can you see that one? So that's an example of one, and it's got only 2 buttons related to logarithms on it. It's got common log, which is log to base 10, and natural log, which you might learn one day, which is log to base e. So you know what, it doesn't matter which one. So that one's called natural log, which is known as log to base e, and if you want to know about that special number called e, tune into a different video. So it doesn't matter which one. It doesn't matter at all which base. So I'm going to use common log. We just call it log a lot of the time. Common log, which is log to base 10. Alright, so we're going to use that one. So we take logs of both sides. So we take the log of the left side and we take the log of the right side. And of course this video assumes that you've done some basic work with log laws and the definition of a logarithm. Now you could just leave it like that, but I'm actually going to write in log to base 10 to make it a bit more explicit. Okay, so I've taken the log to, and the log should be the same base to both sides. Notice the 10 on the left side and the 10 on the right. So that's very important. Okay, so that is very important to do the same thing to both sides. We're solving equations after all. Now, if we have log law 3, that means this index can be, now make sure you keep it together. So you may wish to put brackets there. And that means we can bring that to the front according to log law 3. That's in a different video, and that would be that we then have this, and my equal sign is displaced. Okay, that's better. And we still have log of 7 to base 10 on the right hand side. We want to solve for x, so one thing we could do is to get 2x minus 5 by itself isolated on the left hand side, we need to divide by log of 3 to base 10, which is just has a numerical result, so treat it just like a real number. So we're dividing both sides by log of 3 to base 10. Alright, so that's the operation we're doing to both sides of the equals. Okay, so we had log 7 to the base 10 by itself. We've divided it now by log of 3 to base 10. So 2x minus 5 is log 7 over log 3. So we can use the calculator now. You could enter all of that in the calculator using the log button on just a traditional basic scientific calculator. If you look at the button that literally says log, it is log to base 10. Usually it won't have the little 10 there, but use the log button. So basically you enter it in. Now normally I would do all this in one step, but just to help a bit there, I'm going to separate the numerator and denominator. I'm going to use plenty of decimal places. So you just type in log of 7 using the log key. If you try that yourself, you'll get that if you round it to 4 decimal places. On the denominator on the bottom, log of 3 is 0.4771 using a calculator, and then we just divide it through. That equals approximately 1.7714 significant figures. So 2x minus 5 equals about 1.771. So the rest is just like a linear equation. Well, it actually is a linear equation. Add 5 to both sides. We get 2x equals 6.771. Then we divide by 2, and we get to the same for the significant places, 3.386. Okay, and you can substitute that in there to see if it works. It will work fine. I guess reminds me of, by substituting it in, reminds me of another method which would be guess, check and improve, or iteration, but hopefully you won't need to use that again because you have much more powerful tools at your disposal now. So that was taking logs of both sides, taking the same log of both sides to solve an indicial equation, and now we have a value for x.